In this video, we're going to review how to conduct a one-factor between type of analysis of variance using the data analysis tool in Microsoft Excel. So here we see we have our fictional data. We have a number of measurements obtained from 5 unique and distinct groups of individuals. And so what we want to do here is examine if there is a statistical difference at the alpha level of 0.05 somewhere between 2 or more of these groups, and that's what the analysis of variance technique will do. So to carry out this analysis, I'm going to go to Data in my menu. I'm going to scroll all the way to the right, and I'm going to click Data Analysis. And now I have to go through the packages for the one that I want to use. And so at the very top we see we have ANOVA single factor, and this is a between type of ANOVA. That's the exact one we want. So I click this and I hit OK. Now we need to specify the items in our dialog box. So the input range includes all of the data, and they're grouped by columns. That's how I have this set up. Before I type in the input range, I'm going to click this box here, labels in the first row, because I want to carry forward the labels to indicate the different groups. Now I go into the input range bar, I make it active, and I go back to my spreadsheet and I just highlight all of the items, which includes the column headings. And because I click this box, the column headings won't be factored into the calculations. Microsoft Excel will automatically set the alpha level at 0.05, but if the investigator wishes, they can change this at this point, but I'm going to leave it at 0.05. The default here is that Excel will put the output of the ANOVA into a new worksheet at the bottom. I don't want to do that. I want to put the output on the same page so I can take a look at my data at the same time. So I'm going to move this over, and I want to click the output range box, and I put the cursor inside the output range bar, and I'm just going to click this cell H1, and that's where the output of the ANOVA will be placed. So now that I have all this set up, I'm going to go ahead and hit OK, and we'll see here that we have our output. So I'm just going to widen this column here just so we can see our data. So what Excel will give us is the sample size for each of the 5 groups, and here we have 7 in each group. It will automatically give us the sum within each group, but what I'm looking for here is the average value and the standard deviation. The output will give us the variance, but we can quickly calculate the standard deviation. I'm going to do that right now. I'm just going to give that a label SD, and we know that the standard deviation is the square root of the variance, and so I'm just going to hit the equal sign. I'm going to type in the Excel function SQRT Shift 9, and I'm going to indicate this column here. I'm going to shift, or this cell rather, this cell, shift 0, hit enter, and now we have the standard deviation associated with this average for group 1. And I'm just going to highlight this cell, grab the bottom right hand corner, pull it down, and we have the standard deviation for each of the averages for each of the groups. What we have here at the bottom is the ANOVA table, and this is the standard way of depicting the output of an analysis of variance approach. So what we have here is the source of variation. So we have the between groups variability, we have the within groups variability, and we have the total variability, which is the sum of the between and within groups. And so if you examine the value here for the total sum of squares, it's simply adding the between group sum of squares and the within group sum of squares. Likewise, the total degree of freedom is just simply adding up the degrees of freedom for the between and the degrees of freedom for the within source of variability. We have the associated variance for the between groups and the variance for the within groups. And in ANOVA, the term variance is replaced by the term mean square. Our F statistic is our test statistic generated from the data. F critical is the F value generated from the F distribution given the between and within degrees of freedom and the associated type 1 error risk of 0.05. And associated with our F statistic from the data, we have the actual p-value, which is the one that should be reported. So based upon the fact that the F statistic is greater than the F critical value, we know that we can reject the null hypothesis that there is no difference between the groups at the 0.05 level. But if we have our F statistic that is considerably greater than the F critical, we should always calculate the precise p-value with that associated with that F critical value. So this ends this video on how to use a data analysis package for the one-factor ANOVA, and the next video will cover how to do a post hoc analysis using the average values for each of the 5 groups.